Okay, onto our main program. Our first technical presentation is sharing the outputs of a substantial piece of research into level crossing safety and the introduction of human factors thinking into design. Professor Gemma and Zohre Abedi are also joining us from the University of the Sunshine Coast Centre for Human Factors and Systems Science. Gemma is Professor of Psychology and the Director of Human Factors, with over 19 years' experience applying human factors and systems thinking methods to optimising safety and performance in complex systems, including rail. Zohre is a research fellow with 10 years' experience integrating human factors across transport and healthcare, with a particular focus on delivering practical solutions to real-world problems, which is the focus of today's session as well. Welcome, Gemma and Zohre. I will hand over to you.
Thank you so much, Fiona. Thanks for the opportunity to talk to you about this piece of research today. Just as Paul said, if this isn't working for people, please do let us know. Okay, so this piece of work is really looking at a new toolkit to support human factors integration where we have level crossing safety innovation occurring. I would just like to mention our funders. So thank you to the Federal Department. We were funded under the Level Crossing Safety Research and Innovation Grants. I'd also like to mention my other research team members. So you have myself and Zohre here today, and also Paul, but we also have Dr. Jolene Cox, who contributed to this work. I would also say I've been looking at the people online, and I should also say thank you to a lot of the names that I recognise who did contribute to this work as well. So it's definitely been a collaborative opportunity, I suppose, to put together this toolkit. So I suppose the idea behind the work was, how do we support human-centred innovation in level crossing safety? We know, and I'm talking to people who know this more so, but level crossing safety continues to be a key challenge for rail and for other transport stakeholders as well. I've got some statistics on the slide there. I won't go into a lot of detail, but obviously we know we still have issues associated with collisions between trains and road vehicles. Some of those involve heavy vehicles, which have potential for more catastrophic outcomes. And we also have those additional consequences for train crews who, receive psychological injuries following crashes, as well as the emergency services investigators who attend, and the significant financial costs to the industry as well. And so this particular project was sort of designed to support the broader Regional Australia Level Crossing Safety Program, which has been funding trials of new level crossing safety technologies. And we have some examples of some of those technologies on the slide. There are lots of new technologies that have been proposed to improve level crossing safety, and lots of technologies and other innovative solutions. So just some examples here. So in New South Wales, there's the work that's been done around the dynamic stop signs. There's work being done around in-vehicle navigation systems and providing alerts through those. There's also obstacle detection systems, and I didn't know Paul was going to show the one with the elephants, but there is obstacle detection that might look for equipment malfunction or also look for obstructions on the track. With some sort of back to base alarm as well. So lots of things happening, lots that are focused on road users themselves, but some that are focused, I guess, more broadly in terms of improving safety. But a lot of these technologies or solutions are proposed, but they often kind of hit barriers as they move through the design life cycle, and we're not seeing a lot of implementation. So some of the issues around that can be, the lack of sort of human factors thinking going into that concept. So, are we addressing the right things in this design? And then, field trials can occur, but they're quite expensive and resource intensive. So it really is important to get those concepts right at the beginning. So what this toolkit is really aiming to do is translate knowledge, principles, methods from human factors into a toolkit, really to help stakeholders in the selection, development and implementation of innovative safety solutions to support that trial and then the implementation process as well. The focus of the grant that we received was regional areas of Australia, so passive crossings mostly, but we did try to design the toolkit so it could be useful for any sort of level crossing context that people are looking at. So, just as a bit of an overview, again, I think people are fairly familiar with some of the issues, but potential human factors issues that can be associated with new technologies or new solutions at level crossings can be the design of, the interfaces that we're creating. So if they're quite complex or maybe they're unintuitive, they don't match people's, schema for a warning, for example, because they're quite new. Could also be poor warning or alert designs, so, alarm fatigue or false alarms. Inadequate consideration of user diversity, so whether that's different road user types in terms of does this work for drivers as well as heavy vehicle drivers, motorcyclists, etc. Could also be other aspects of diversity around abilities or comprehension of different language, for example. We can see lack of trust in new systems, because they are new, and that can occur, I guess, at the road user level, but also at other levels of the system. So as we work through that engineering process and get adoption within organisations. So that's something that needs to be addressed. And also, potential for insufficient familiarisation in that sort of implementation process. So that's whether that's with sort of end users who might be road users, or it could also be maintainers. So are people receiving support to maintain these technologies or solutions? As well as, other people who might be involved in the system, like train drivers or track workers. So again, this audience knows this pretty well, but just to sort of define what we were wanting to do was to support human factors integration processes. So HFI being the formal process of implementing human factors knowledge, principles and methods in the design lifecycle to ensure that basically we're designing things that fit real world behaviour and needs, and that our solutions are safe, usable and accepted by end users and stakeholders. So I might pass over to Zohre at this point to talk through some of the details about the toolkit.
Thanks, Gemma. Hello, everyone. The aim of this project was to develop a publicly accessible evidence-based toolkit to support stakeholders in during the integration of human factors principles into the design and implementation of innovative level crossing safety solutions. The project involved two main stages. Before getting into these stages, we undertook a comprehensive literature review and a technology scan to identify various technologies currently used for level crossing safety around the world. And then in the first stage, we had 17 workshops with 46 participants from 15 stakeholder organizations. And during these workshops, we wanted to explore key challenges perceived by these stakeholders, their needs and current practices relating to rail level crossing safety. After identifying stakeholder requirements during stakeholder workshops, we developed toolkit draft materials and presented these materials to stakeholders during 2 online consultation sessions with 27 participants from 21 stakeholder organizations. In these sessions, we obtained stakeholders' feedback on the utility of these materials in supporting decision-making throughout the life cycle of innovative safety solutions. Next slide, please. Thanks. So stakeholder workshops identified some of the key barriers impeding stakeholders from implementation of innovative technologies at level crossings. These barriers included those related to organizational capacity and resourcing, such as gaps in expertise, time, and data access, inconsistent evaluation and limited funding, issues related to stakeholder alignment and collaboration, such as coordination and communication issues and stakeholder misalignment. Some of the challenges related to socio-political and public acceptance, such as risk-averse cultures, public and community acceptance, and political and legal sensitivities. Our participants also identified some barriers related to technical and system integration, such as infrastructure and integration issues, as well as technology limitations. And finally, our participants identified some key barriers related to human factors and behavioral considerations, such as poor human factors integration, user interaction issues, contextual and environmental barriers, and inclusive design challenges. Stakeholder workshops also lead to identifying some requirements, some key requirements. These for the toolkit. These requirements included guides and reviews to help stakeholders with providing knowledge resources, training materials, and case studies. Standard and templates to help them to ensure a consistent data collection and reporting practices. And checklist and prompts to support systematic considerations of human factors issues in decision making and risk assessment. Our participants also wanted to see process maps and models as part of the toolkit to show where human factors methods fit within project lifecycle. They also wanted to see documentation and tools as part of the toolkit to support transparent record keeping of decisions, options, and rationale behind decisions. And finally, they wanted to see embedded framework to be included in the toolkit to provide human factors prompts embedded in existing risk tools and data platforms. Based on these requirements and following the stakeholder consultation sessions, we developed the Level Crossing Human Factors Integration Toolkit, or LXHFI Toolkit, which is a publicly available online toolkit currently hosted on the University of the Sunshine Coast website. Next slide, please. Thank you. The toolkit includes several resources, including 3 short animation videos aiming to raise stakeholders' awareness of the importance of considering human factors throughout the project lifecycle of innovative solutions at level crossings, providing different human factors considerations, providing an understanding of different human factors considerations associated with these technologies, and presenting an overview of the LXHFI toolkit and showing how it supports the project lifecycle. And now we're going to play one of these videos, which aims to identify various human factors considerations related to these technologies. I think it's mute, Gemma, if you could. Yep.
Same road, same driver, same train. But the decisions made long before this moment will change everything. In one version of this future, decision makers dismissed a new technology, concerned it could introduce new risks. The system stayed the same. The safety issues stayed too. In another future, a technology was installed, but designed without a structured approach to considering the user interaction. It left users uncertain and reactive. But what if this was part of the plan? What if designs supported real people? Because at every level crossing, it's not just the signs or systems that matter. It's how people experience them that keeps us safe. That's why it is vital that we engage with human factors professionals right from the beginning of a project. This makes sure that new technologies designed to improve safety are aligned with what users actually need, promoting safe decision-making and making level crossings safer for everyone.
Thanks, Gemma. Then another resource in the toolkit is a project lifecycle diagram and guidance for innovative solutions at level crossings. And the aim of this document is to help stakeholders and project teams identify where human factors, methods, and expertise may be most useful, and to ensure the design, implementation, and operation of effective new solutions that support level crossing safety. The project lifecycle includes 7 phases, and each of these phases include a set of steps. These phases include pre-concept, concept and planning, design, development, and build and integration, acceptance and testing, in-service and decommissioning. The life cycle also includes several cross-cutting activities that should be undertaken across all phases of the project life cycle, such as project management practices, interdisciplinary collaborations, and stakeholder engagement and risk management. We have developed a set of materials to help stakeholders meeting their requirements across each of these phases. Gemma will walk you through these in more detail.
Thanks, Zohre. So yeah, as Zohre said, we've developed some guidance material that support each of these phases as well. So, for example, Zohre mentioned that we conducted a literature review at the beginning of the project. We have actually included that in our toolkit to help with some of those decision-making activities around the sort of pre-concept and concept and planning, so that we're addressing the issues that are known in the literature to lead to level crossing crashes. We also have some generic level crossing task analyses with the idea that people can use those and adapt them, and I'll talk about those a little bit more in a moment. We also put together some interface design guidance for use in the design phase, when we're getting into the process of making some selections around what warnings and alerts look like. So we've referred to previous standards and research around that. We also have, and I think this came through really strongly in the initial requirements workshops and in the consultation, that really needs to have a risk management approach underpinning various phases of the life cycle. So we developed some risk assessment prompts that could be used at different stages to help people think through the risks that are occurring, say at the design stage, but also once we're in service and even at decommissioning as well. And also put together some evaluation guidance as well. So while we are going through that process of, early prototyping through to field trials or simulation trials, if they're occurring, around, measures, metrics, good practice in terms of evaluation to help us make those evidence-based decisions about which solution should go ahead. I think that's it for the main tools. We also have some useful resources, and if you do go to the website, you'll find this diagram, and you can actually click on each of these phases and get further information on where each of those tools can be used. So we hope that's quite helpful. I did mention, and I think we still have a little bit of time, so I wanted to go into a little bit of detail on just one of the guidance materials that we put together, which was the generic level crossing task analyses. So this document really, the idea here was to assist human factors specialists, probably more specifically, as opposed to other stakeholders, to help them with their process of either analysing existing behaviour at level crossings that could be influenced through new technologies, so thinking through, which technologies could assist with the tasks, but also once we have a concept, to consider the impact of new technologies on existing user behaviour at level crossings. So a couple of uses there. And a task analysis can also form the basis of additional analyses that people may need to do. So if we're thinking about workload or training needs analysis, things like that. Within the document, there's 3 generic task analysis diagrams covering behaviour associated with different level crossing types. So I think we have one for an active crossing, one for a crossing with a stop sign, and one for a crossing with a give way sign. Obviously intended to be a guide with the idea that it would be adapted as required to support whatever analysis needs the user has for this guide. So I'll just go into a little bit more detail just to give you an example of one of the task analyses that we do have in the document. So this is one for looking at road user activity at active crossings. So this is crossings with flashing lights only. Obviously difficult to read on the screen here, it's a bit small. So I'll just we'll just zoom into the very top level. And just so you can see, so we've sort of looked in the task analysis about which road user type might undertake a task, and we find that there are some differences. For example, heavy vehicle drivers who may need to think about short stacking, for example, as they're approaching the crossing, as well as motorcyclists and cyclists may have some different behaviours. But overall, with this task analysis, we had a sort of higher level goal, which was around the safe and efficient separation of road and rail traffic at a level crossing, and we had 6 sub goals that were defined around that. So obviously controlling the vehicle, it's a task the road user and also the road user is undertaking, detecting the presence of a level crossing, detecting the cue that you need to come to a stop, deciding whether to stop or proceed through the crossing, stopping at the level crossing, or proceeding through the level crossing. And we have the plans in there around, the order in which or the sequence in which these might be undertaken. If we dig into a little bit more detail on one of our sub-goals, so in terms of detecting the cue to stop, it may be that the road user perceives other vehicles who are stopped at the rail level crossing, and that's the cue that they get that reminds them that they need to stop. It might be they also have to comprehend the requirement to stop, so they have to sort of understand what's going on. They may conduct head checks to look for trains and see a train approaching, or they may hear a train approaching with the train horn. They also have to comprehend that it's a train approaching and that's affecting them at the level crossing. So basically, just to give you an idea of the level of detail that is incorporated in the task analyses, and obviously the idea being that you can sort of map to that if a new technology is going to focus on, supporting some of these tasks, or if it might interfere with some of these tasks as well. So in terms of a risk sort of point of view. So I guess just as a bit of a conclusion, so the toolkit sort of aims to help stakeholders apply human factors principles in the development and implementation of new level crossing safety solutions. The idea is to support safe, user-centred and compliant designs by identifying and mitigating human factors related risks and aiming to improve safety at regional level crossings in particular. And also I think a key thing is sort of building confidence among industry, government and the public. So Zohre touched on some of the barriers that were discussed when we did the industry consultation. And I think, I think sometimes human factors can be used as a reason not to innovate, and because there might be risks. But I think it's important to go through that risk process, risk assessment, risk management process, because we could be at risk of doing nothing where some innovation could improve the situation that we have currently. So with that, wanted to say thank you. Also wanted to mention, again, thank you to the department. Thank you to everyone who participated in the workshops and provided feedback during our consultations. I would also mention, I might try and put into the Q&A the link to the website if you would like to have a look. Zohre and I also have hard copy materials available. So our email addresses are there. If you would like a hard copy of the toolkit material sent to you, we can arrange that as well. So with that, I might stop for any questions.
Thank you very much, Gemma and Zohre. That was my first question, is where do we find it? So I think if you can provide that link in the Q&A, that'd be fantastic. Otherwise, we can put it up on the Arizo site at the end of the forum as well, where we'll hopefully put most of the materials that are shared today. Yeah, that was a great presentation. There's a question, and I suspect a lot of people may ask, they're very familiar with LCAM as the industry tool around level crossings. This is different to LCAM, but could you talk a little bit about how the two relate to each other, what that interface might be, how people might use them alongside each other or together when they're looking at crossings and risk assessing and design?
Yeah, that's a really great question, actually, Fiona. And we do reference LCAM in the toolkit materials in terms of that sort of pre-concept stage, thinking around or gathering as much sort of data and intelligence that that you can around what's happening at crossings. So I think LCAM, is a good repository of information about potential risks at crossings, at particular crossings. And so I imagine that a infrastructure manager or whether it's local council or government, they might want to look at, the crossings that they have in their area and what kinds of risks are coming through from those LCAM assessments. I think that could be a useful input into that sort of early phase of considering the best approach to take. Yeah. Oh, sorry, Fiona, you're on mute.
it was bound to happen at some point. Zohre's just put a link in the Q&A if anybody wants to go in and have a look and see the toolkit itself. There's another question around a couple of years ago. There was a level crossing toolkit released in Victoria around human factors integration into crossing design. My understanding is this is separate to that, but perhaps complementary. It's an additional resource that people could use, but it's coming out of the University Sunshine Coast instead.
Well, I guess I can comment on that as well, Fiona. I'm familiar with the other toolkit, which is a great toolkit. That's really the way I see the difference between the two is that the 2024 or the existing toolkit is really about upgrading existing level crossings using, I guess, controls that are already known. They're already maybe in standards, and it's about that sort of upgrade process within the sort of existing countermeasures or design approaches that we know about now. Whereas I suppose our toolkit was really sort of thinking about those new technologies or new solutions that are quite innovative and quite different, and we're sort of going back to basics in terms of really considering their design and the potential risks that they might bring into the system. So I think they're trying to do two different things actually. So I think they are complementary from that perspective. Very much so.
Fantastic. And obviously the more tools we have as an industry that help inform good design, the better. If anybody else has any questions for Gemma or Zohre, just pop them in the Q&A and they may hang around for a little bit longer and answer them while we're on a break. Otherwise, thank you both tremendously for that presentation. It's a really interesting piece of work.